presentation today is on 5 testing best practices and how these practices can help you improve your testing processes and teams and so forth. Now, to be clear, when I say best practice, I'm talking about an approach to doing something that will generally give good results when applied in an appropriate and thoughtful manner. So these are not simple recipes for success that can be followed without thought, but rather more general guidelines that, when appropriately tailored and applied, will help you improve what you're doing, hence the name best practice. So for testing, there are a number of best practices. I've picked 5 of them for this particular presentation because I feel that they are generally applicable and would be useful to the largest number of people. There are probably others that I could easily have picked as well, but I think you should find, if you're in the testing business, that most of these are things that you can consider and benefit from. So we'll look at risk-based testing, the importance of realistic objectives and metrics for those objectives, the need for continuous test process improvement based on data gathered on previous projects and efforts, the value of trained and certified test teams, and the ability to distribute testing work intelligently across various partners. Excuse me. So I'll start with the analytical risk-based testing. So analytical risk-based testing strategies, what you do is, prior to the development and execution of tests, you do an upfront analysis of the risks to the quality of the system. Now that's kind of a mouthful there, so let me explain that. So when I say risks to the quality of the system, what I'm saying is there are bad things that could happen with the product that would reduce the level of satisfaction that customers, users, and other stakeholders have with the product in actual use in production. So an example of a quality risk would be, say, for an e-commerce application, system calculates the wrong total order, or system responds too slowly to user input. So those are specific quality risk items, and the quality risk items can be grouped together into categories such as functionality, performance, usability, and so forth. Now the upfront analysis is that what we do is, rather than wait during test execution to try to understand the risks, as some people have advocated, what I'm advocating here is, before we do anything, and I mean anything, right, the plan, estimate the testing, create data, set up environments, and so forth, we think about the risks. We think about what needs to be tested. And so we go through a process of identifying the risk items, such as the examples that I just gave about accuracy and response time. And then for each risk item, we assess a level of risk. And the simplest way to do this is to look at the likelihood of a bug related to the risk item existing in the product when it's delivered for testing, and the impact of a bug related to the risk item existing in the product delivered to production. So based on likelihood and impact, we can come up with an overall aggregate level of risk for the risk item. And then that aggregate level of risk will determine the extent of test coverage that is desired, whether we want to do extensive testing, broad testing, cursory testing, or perhaps just opportunistic testing as time and opportunities present themselves. We can run the tests in the proper order based on the level of risk, starting with the most risky and ending with the least risky tests. And should we run out of time, as sometimes happens with testing, that there's more testing work to be done than time available to do it, we have an intelligent way of triaging our tests by dropping the least risky tests while retaining the most risky ones. Here's an example of a quality risk analysis from a client that we helped do a risk analysis. This is from CA, or formerly known as Computer Associates. And what we can see here, let me see if I can get a highlighter up and running here. We've got the quality risk category here, serviceability. See that one there? And then We have a number of risk items. You see that these have a risk ID number, which aids traceability of tests to risks. And then we have the specific quality risk items listed here, and each one has a likelihood and an impact, and those multiplied together give us the aggregate level of risk, the risk priority number, which is shown here. And that's used to determine the extent of testing, and the test cases inherit the risk priority number of the tests, the risk items from which they derive, which allows us to sequence the tests in risk priority order. And you'll see we also have the tracing to the product requirement specification, or PRS, and also the detailed design specification, or DDS, given here. This allows us to update the risk assessment should the documents change by checking the sections in which the change occurred and updating the risks that are associated with changed areas of the requirements or design specifications, rather than having to go through the entire risk analysis to try to figure out how the change is impacted. This, by the way, is described in a case study. Oh, excuse me, got ahead of myself there. Described in a case study which is posted on the RBCS website. That's rbcs-us.com. If you go to the resources articles page, there's an article on risk-based testing, and this is the article which describes this this case study for CA. Excuse me. Now, what are the benefits of risk-based testing? Why should we do this? Well, for one thing, it provides a nice organizing principle that it turns out to be quite robust in terms of the things that tend to go on in projects. You can identify clearly what's to be tested, in what order and how much, what can be dropped if necessary. And this is something which is quite transparent, because the stakeholders participate in the risk identification and the risk assessment. They understand what is to be tested because they participate in that decision. At the same time, it avoids dragging testing stakeholders, external testing stakeholders such as developers and business analysts and so forth, into the complexities of the test cases themselves. So rather than, as some people do, pulling the various developers, business analysts, and so forth into detailed test case reviews where their eyes are typically glazed over within 5 minutes, we're going to instead ask them to participate in a discussion about what is to be tested, not specifically how it is to be tested. So that's quite a benefit, because it builds a consensus and aligns expectations around what's to be covered. Because the tests are ultimately executed in risk order, this will tend to find the more important bugs earlier in the process and the less important bugs later, because likelihood and impact are the two factors that we're going to look at in terms of sequencing the tests. The higher the likelihood of finding the bug in general, the earlier in the testing process we will run the test, and the higher the impact, the earlier we will run the test. So when both likelihood and impact are high, these being the really scary bugs, then we'll tend to run the tests that are associated with those earlier. So that's quite a benefit as well, because one of the things that can be very frustrating for people outside of the test team is the late discovery of important bugs. And this coming to the project status meeting at the very end of the project and saying, wait, I found a showstopper, is never anything that endears the test manager to the rest of the project team. So finding the important stuff early is a good benefit of risk-based testing. Now you might say, oh, well, wouldn't that happen by itself? But actually, it doesn't. What we typically find with clients that are not doing risk-based testing is that actually there tends to be a disproportionate